Section 2.1 is patterns and inductive reasoning. So let's talk about inductive reasoning. Inductive reasoning is reasoning based on patterns. So there are two kinds of reasoning, inductive and deductive, and we're talking about inductive reasoning today. So when we see a pattern, sometimes we can tell something about what's going on. So here's a pattern, 3, 9, 27, 81. And if I ask you to figure out what this pattern is, you would probably say that each number is multiplied by 3. So the next one in the series would be 81 times 3, which is 243. And we can continue the pattern by multiplying times 3 every time. I'm sorry. Yeah, that's right. I thought I multiplied wrong. By multiplying by 3 again. So this is a pattern that we can easily recognize. Take a look at this pattern. Can you make a reasonable guess as to what the next one in the pattern would be? So hopefully you see that it's every other letter, A, B, C, D, E, F, G, H, I, J, K, L, M, etc., etc. How about this one? So what is the next name for polygons? If that's a 3-sided, then a 4-sided, then a 5-sided, what is the name of a 6-sided polygon? That would be the next one in our sequence. So you can see that it's pretty easy to see patterns as we go and use inductive reasoning to find the next term in each pattern. A conjecture. A conjecture is a conclusion that you reach using inductive reasoning. So we can make conjectures, which is kind of what we did in the last slide. We made a conjecture about what the next in the series should be. So what conjecture can you make about the number of regions that n diameters form based on the information given? Be sure you're writing this down because you'll need it in your notes. So the first is that a circle with one diameter is split into 2 regions. So if you draw a circle and put one diameter, we get 2 regions. Let's continue on and see if we can develop a pattern and then make a conjecture about this pattern. A circle with 2 diameters, so if I add a second diameter, now I'm split into 4 regions. A circle with 3 diameters now is split into 6 regions. So hopefully we're seeing a pattern develop here and we can make a conjecture. A circle with n diameters, any value or a certain number of diameters, would be split into how many regions? So hopefully you see that that's 2 times n. So a conjecture is something that we think is true based on our inductive reasoning of a certain pattern. Now, one of the problems with making a conjecture is that sometimes we jump to our conclusion too quickly. So, what is the next in this sequence? Put the sequence down and write down the next value that you would put in this sequence. So, some of you may have put 9. 1 times 3 is 3, 3 times 3 is 9, 9 times 3 would be 27. Others of you might have said 5, add 2, add 2, add 2. So with just a couple of terms, we don't have enough data to come up with the sequence. So watch out with your conjectures. Make sure that you have enough data first. So let's look at a more complex problem. Can you make a conjecture about the sum of the first 30 even numbers? Well, the first thing we have to do is make sure we have enough data. So the first even number is 2, and if I just add 2 to itself, I get 2. If I take 2 even numbers, 2 plus 4, I get 6. If I do 3, the first 3 even numbers, 2 plus 4 plus 6, now I have 12. The first 4 even numbers would be the first 3 plus 8, which would be 20. The first 5 even numbers would be 20 plus 10, which would be 30. So let's see if I can see a pattern. If I add the first even number, just one even number, I get 2. If I add the first 2 even numbers, I get 6. If I add the first 3 even numbers, I get 12. The first 4 even numbers gives me 20. The first 5 even numbers gives me 30. We could do one more. The first 6 even numbers would give me 42. So stop a minute, think very carefully, and see if you can come up with a pattern for the sum of the first n, or the first 30 even numbers, without adding all the way up. So pause and see what you can do. Okay, so this pattern was a little tougher to see, but the pattern is that the sum of the first 30 even numbers, or let's go backwards first and do a general conjecture. The sum of the first n even numbers is n times n plus 1. So to get the sum of the first 3 even numbers, I do 3 times 4 and get 12. To do the sum of the first 4 even numbers, I do 4 times 5 to get 20. So the sum of the first 30 even numbers would be 30 times 31, which is, I didn't do this, 930. So that would be the sum of the first 30 even numbers. So patterns can get pretty complex. We're going to take a long look at some patterns in our lesson, but you need to sometimes think outside the box a little bit. So keep that in mind as we look for our conjectures and our patterns. Okay, whoops, that should have been our heading. Make sure you have enough data to make a conjecture. Sorry about that. Okay, using data to make a prediction or a conjecture. So the number of backpacks sold in March was 5,000 backpacks. In April, May, and June, the number of backpacks sold decreased by 500 backpacks every month. Can you predict anything about the backpacks sold in July and August? So let's look at our pattern. March, we had 5,000. April said it decreased by 500, so we're down to 4,500. May, down to 4,000, and June, down to 3,500. So, can I make a prediction here about July and August? Well, the pattern seems to say that we would sell 3,000, then 2,500. Then if I continue the pattern, September would be 2,000, etc., until I got down to 0 backpacks. So this doesn't quite make as much sense as our other patterns. Now, our other patterns were strictly algebraic. They didn't have any real-world consequences. So when we are looking at patterns in the real world, we have to take other things into consideration. Hopefully you see that in August and September, this should skyrocket back up as we get to the beginning of the school year. So be careful. Even though it looks like we have enough data to continue the pattern was pretty steady and looked pretty obvious, we do have to take into account when we have some real-world situations going on. The other way to deal with patterns and conjectures is to find a counterexample. Not all conjectures are true. You can prove a conjecture as false by finding at least one counterexample. So let's look at some conjectures and see if we can find a counterexample. If the name of a month starts with the letter J, it's a summer month. June, July, those are both summer months. Can we find a counterexample? Of course, January. So although at first glance it looks like this is a good conjecture, by finding one counterexample, we can prove the conjecture wrong. How about this? See if you can find a counterexample to prove this conjecture wrong, or possibly the conjecture is true. You can connect any 3 points to form a triangle. So again, at first glance, this seems like a pretty good conjecture. I, however, know that there's a counterexample. Did you find it? So the counterexample would be that if 3 points are collinear, we cannot form a triangle with those 3 points. So again, here we're looking for counterexamples to prove a conjecture false. And that's all we have for this lesson.